All right, so 1.3, we are going to focus on algebraic expressions today. Okay, and then by the end of today, you'll remember all these wonderful things because this is all review for you. So we're going to talk about the type, the terms, the degree of a polynomial, the sum, the difference, and the product of polynomials. We'll do some operations, and then we'll do some factoring. So we're going to use these definitions to help us give 2 examples of each. Okay, so there's many different examples of monomials. You can have something like 3x, so a coefficient and a variable. Okay, you can also have something like 1/2 x to the 5th. Okay, so it's just the one term, so you cannot have any addition or subtraction in between these. Okay, are there any that you guys came up with that you want to check with me to make sure it's a monomial? All right, and then a binomial is a sum of 2 monomial terms. They just call it a sum, but you can have subtraction. It would be like adding a negative sign. Okay, so one basic one would be x plus 3. Okay, and then the other one I did was 2x squared minus 5. Okay, a trinomial is going to have 3 terms. So these are the ones you guys are used to factoring, something like this. That would not be factorable, but that is the form. You can also have like a cubic trinomial. Okay, and then anything that has more than 3 terms is just a polynomial with that many terms. So here's an example of a cubic polynomial with 4 terms. Okay, and any polynomial can have any number of terms. So monomials are polynomials, binomials are, trinomials are, and then we just say a polynomial with however many terms. Okay, now do you guys remember how to find the degree? Yep, it's always the highest exponent. Okay, so the highest exponent of the variable. And the reason why I'm specifying that it's of the variable is if you had like 5 to the 3rd, okay, that wouldn't be a degree 3, that would be a constant term. Okay, so I want you to come up with an example of a trinomial with a degree of 4. So a trinomial with the degree of 4, and then a binomial with a degree of 1. Okay, so I want you to do that, and then just check in with somebody in your row. Make sure you guys have those correct. Okay, so if it's a trinomial, you have to have 3 different terms. If there's a degree of 4, you have to have x to the 4th somewhere in there. You can have coefficients. You don't need coefficients. This is just one example of a trinomial with a degree of 4. Okay, a binomial has to have 2 terms. If the degree is 1, you could have something like 2x plus 3. Okay, the degree on x just has to be 1. All right, any questions for me about those? The degree, the number of terms, all that's coming back? Still there, never left? All right, so when we are doing operations such as addition and subtraction, you can add what is called your like terms together. Okay, and like terms are defined as terms that have the same variables and the same variables also have to be raised to the same power. Okay, so terms that have the same variables raised to the same power. So if you had x cubed and x squared, you couldn't add those together because it's not the same power. One thing you want to remember when you're subtracting polynomials is when you are subtracting and you have a binomial or a trinomial, with that minus sign, you have to distribute the negative. Okay, now we are not going to do examples together of adding and subtracting polynomials. That's something that people usually remember without having to see it again. So you'll just be practicing that in your homework, and this is just to help you remember that prior knowledge, okay? All right, so to find the product of polynomials or another algebraic expression, you are going to use the distributive property. Okay, and we do this repeatedly. So if it's a binomial and a trinomial, you're going to have to do the distributive property twice. Okay, remember that FOIL is what we use when we're multiplying two binomials together. Or if you've had me before, you know I like to use FEAL. I like to do the inside and then the outside. And when you do multiply, remember, you have to use those laws of exponents. So if you're multiplying, you're going to add the exponents together. Okay, so we're going to talk about these special product formulas for when you factor. When we factor, we take out the greatest common factor first, and then we look for special patterns. So if you have two values that are any real numbers, we're going to call them A and B for these. Then we're going to remember all of these special patterns that we have. So the first one comes from the difference of two squares. It's going to be written as multiplying. So if you have A plus B multiplied by A minus B, remember that that's going to be the first term squared minus the second term squared. Okay, and then the square of a sum, there's a formula for this. You can also just FOIL, but you're going to start to recognize there are certain patterns here where you would do A times A to get A squared. AB plus AB would be 2AB, and then B times B would be B squared. So that would be the square of a sum. The square of a difference is very similar. You square the A's and then you subtract AB. Okay, that happens twice. And then what is negative B times negative B? It's a positive B squared. Okay, so that's why this is positive here. Again, these are special patterns that you might start to notice so that you can do this right away. You can also use FOIL. You will end up with the same answer. Okay, now we also have the cube of a sum and the cube of a difference. So again, you could FOIL, or you can apply this pattern. Okay, so we have A cubed plus 3a squared b plus 3ab squared plus b cubed okay, and then again, when you're doing this, you can multiply this out several times. When we did this last year, we actually used Pascal's triangle. Do you guys remember doing expansions with Pascal's triangle? So like if you had it to the third power, you had to go to the third row in Pascal's triangle, and then we would put those in front. So if you guys remember Pascal's, right, how you're creating it, okay, when the first row is row 0, row 1, row 2, row 3. Look at the coefficients here. See how it's 1, 3, 3, 1? That's exactly what this pattern is. The binomial expansion with Pascal's triangle. So you always just do the first one to the third. And you do not have to have, sorry, this is minus. You do not have to have any of these memorized because there are just so many different patterns to them that you can figure them out in different ways. Okay, so this is really just to show you, hey, anytime you have this structure, this is always going to happen. So I'm not sure if you remember when you did binomial expansion last year, but you do have alternating signs when you have a negative in front. So this is just a minus. I started writing plus because I was looking at the one above. And then you can, if you want to use these formulas, you can apply them using substitution. So whatever your A and your B are, you can use those, you can apply them. If you want to just do it how you've always done it, that is fine too. Okay, now we're also going to recall what happens when you multiply a square root by itself. So if you multiply, here, actually I'm going to do the example first, and then we'll go there. If you multiply root 8 by root 8, what do you get? 8. Okay, you can think of it as, oh yeah, it's the square root of 64, and the square root of 64 is 8. What do we call that number underneath? Remember from yesterday? Radicand. Nice job. Okay, so it's always the value underneath. Okay, now this also applies if you have different variables. So if you do the square root of 2x times the square root of 2x, it's just going to be 2x. It also works if you have a binomial. So if you are trying to multiply the square root of y plus 1 times the square root of y plus 1, that is going to be equivalent to y plus 1. Okay, the reason why is because really this is what you're doing. You're squaring, you're taking the square root of a square. So when that happens, they cancel out, you get y plus 1. Okay, so again, today I'm giving you a lot of review from things you've done before, and you're going to be applying these to your practice problems, okay? All right, so I asked you earlier what you got to take out first when you're factoring, and you said the GCF. So the GCF means the greatest common factor. And that is just the largest value that divides evenly into both terms. You have to make sure that you look at numbers and you look at variables. And normally we do those two things separately. Oh, yeah, yes, whichever terms you have. Yeah, sorry. And so we're going to identify the greatest common factors into the expressions below. hard. Yes, they can, which is probably one of the reasons why I won't let you use it, because I want you to know how to do it. So when you have your two values, the 6 and the 16, that's what we're going to look at first. Okay, so if you need to, you can list the factors, right? A lot of us can do this in our head. So what goes into 6, 2, 4, and 6. Okay, what goes into 16? 2, 4, 8, 16. Okay, so what's the largest one that goes into both? 2. So you can take out a 2. That's the largest number you can take out of both. Okay, you'll never take out a 1, okay, because it would be the same thing. Okay, now with the x's, here you have x squared, here you have an x. What is the largest that you can take out of both? An x. You can't take out x squared if you only have one x. So when you're finding the GCF, it's always going to be the lower of those two. So if you have y to the 6th and you have y to the 4th, the most you can take out is y to the 4th. And yeah, for this one, I said both terms just because we were doing this. You can also say just each term. More than 2. Okay, so then for this one, we have -3, 6, and 2. Okay, so 3 and 2 both go into 6, but the problem is 2 doesn't go into 3, 3 doesn't go into 2. The only thing that's going to go into all of those is what number? 1. Okay, so we don't even have to write that down because 1 times anything is itself. Okay, so now I want you to go through and I want you to find what the GCF is. So what variables can you take out of each of them? And write that down. Okay, so for the x, what's the most number of x's you can take out of each? 1x. What about the y's? 1. What about the z's? 1. Okay, so x, y, z, that is your GCF. That would be optional. So we're going to ask if we could take out the negative. You could. So if you put the negative x, y, z, it wouldn't be wrong to take that out. It would just change the signs. You just don't have to do it. But you could. All right, and then we are going to talk about the wonderful world of factoring. Okay, so when you are factoring, you should always look for your common factors first. Okay, what they have in common. So I always tell my students that you can remember the rules of factoring easily because they're just like the rules of dating. Yes, dating. Sometimes you will use one of these steps, but you can use more than one in a single problem. Okay, so when you first meet somebody, right, you want to find out what you have in common. Right? What do we have in common? We have the same interests. In factoring terms, that's just going to be your GCF. Okay, then we want to see what's special about them. What makes them a cool person to hang out with? In the factoring world, that means you're going to have special patterns. So I already told you about one special pattern. We talked a little bit about the difference of two squares. Remember, we also have the difference of cubes, the sum of cubes. We have some perfect square trinomials. Okay, and then if we're feeling generous, ladies, we just guess and check it out, right? Give them a chance. Okay, so you're just going to guess and check. So you're always going to want to guess and check it out. Okay, and then when we're checking with factoring, you can always check by distributing or using FOIL. Okay, so when you are looking for those special patterns, it's nice to just have a reminder of what those are. So the difference of squares, you will have a squared minus b squared. And then that is going to factor into a plus b and a minus b. This is the most common one. Okay, that pops out a lot. And it's the difference of squares because we're going to be looking for perfect squares. You can also use the perfect square addition. And these aren't as common because you can FOIL, and a lot of people do that naturally with the perfect square addition and the perfect square subtraction. Okay, but if you notice it starts and ends with a perfect square and the middle is double the product, okay, then you can have the addition or the difference. So that would be a plus b squared. And so if you wrote a plus b times a plus b, you can always just write that as a square. Or you could have a minus b times a minus b, and that would be squared. Okay, and then you can also have the sum of cubes. So a cubed plus b cubed and a cubed minus b cubed. Notice that for the squares, it's only the difference. You can never split it up if it's the sum. Okay, for this, you can do the sum and the difference. Okay, if it's cubes, you have both. If it's the squares, you just have the difference. Okay, and then this pattern, which you may or may not recall, if it's the sum, it's going to start with the sum, a plus b, and then it's a squared. This is the opposite, and then plus b squared. These will always be positive because you're squaring them. Anytime you square something, it's positive. Okay, and if you have the difference, you start with the difference, and then you do the opposite sign here, and then again, it's plus, because whenever you're squaring something, it's always going to be positive. Okay, so when we're doing this without a calculator, it's important that you are able to recognize the perfect squares and the perfect cubes. Okay, recall that perfect square is just a number that when you take the square root of it, you get a whole number. And then the perfect cube, when you take the cube root, okay, you get a whole number. So, starting with 1, I want you to list the perfect squares up to 10 squared. Can you guys do that without me, the list? With the perfect squares up to 10 squared? Right, so 1 squared is 1, 2 squared is 4, then what? 9, 16, 25, 36, 49, 64, 9 squared, 10 squared. Yay! All right, now the real fun. Now we're going to do the cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed, 4 cubed. 5 cubed. Good. Do you guys know 6 cubed? No, 7 cubed? No. 343. 8 cubed is 512. Then 729. And what's 10 cubed? 1,000. Okay? So now that you have these, you'll be able to recognize them. What you'll be doing with some of the larger numbers is the factor tree. Okay? All right. So remember that variables, those are also going to be perfect squares or cubes. The most common perfect square that you're going to see is x squared, but x to the 4th, x to the 6th, x to the 8th, those are all perfect squares too. And then what do you notice about all of their exponents? Yep, they're all even. Yep, divisible by 2. Okay, so if you were taking the square root of x to the fourth, what would that be? X squared. You took the square root of x to the sixth. How many times is 2 going to 6? 3. Okay, see what the pattern is? You take the square root here, 2 goes into 8, how many times? 4. So this is based on what we were doing yesterday. Okay, so the most common perfect cube is x to the third, but you could also have x to the sixth and x to the ninth. And then what do you notice about those exponents? Yeah, divisible by 3, or you can say multiples of 3, same thing. Okay, so if you do the cube root of x cubed, we know that that's just x. But if you do the cube root of x to the sixth, that would be x squared. And then the cube root of x to the ninth, x to the third. It's a lot of concepts. Remember, the first 3 sections are really dense. Okay, and then I just wanted to notate to you that the book is going to show you how to factor expressions that have fractional exponents, but you are not going to be assessed on that, so it's not going to be in your homework. So if you want to see what that looks like, you do have an example in your book, but it's not something you'll have to know for your assessment. Okay, so with factoring, remember that you can factor by grouping. Polynomials with 4 terms can, nope, sometimes, because sometimes you have things that are not factorable. Okay, and sometimes if you do the parentheses, you might not be able to find something where they break down, and that's because polynomials with 4 terms, they might have solutions that are not whole numbers. You might have imaginary solutions, you might have radical solutions. You guys remember how we found solutions when they couldn't be factored last year?
Question.
Well, we did something before we got to the quadratic.
Oh, we multiplied.
We had to do that synthetic division, remember, until you got down to a quadratic? Yeah.
Yeah.
I'm scared because you guys decide about that. We're going to do that in chapter 3 again. Okay, so, yeah. When you are grouping, it's usually best to make sure it's in standard form. Okay, so you start with the highest exponent and work your way down, and then you can group the first 2 terms together and the last 2 terms together, and then you're going to factor out the common factors of the GCF. Okay, and I know that doesn't sound the best, we factor out the common factors. Okay, when you are factoring something out, you are dividing it. Okay, whatever is left inside of the parentheses is the same for both groups. You can factor out that expression because it is a common term. So if you have the same in each parenthesis, then you are factoring that out again. Okay, so we're going to do some examples with that. And then if it can't be factored using the grouping method, we're going to explain why. So when you're grouping, when you have the 4 terms, we'll just check to make sure it's in standard form. So 3, 2, 1, and then no variable. So we're going to group the first 2 together, group the second 2 together. Okay, good. I thought that you guys would remember this. So I'm going to go over it quickly. So when you're doing that, what can you take out of both 2x cubed and x squared? X squared. So when you take out the x squared, you are dividing. So the 2 is going to stay, 2 divided by 1. What's x cubed divided by x squared? X. What's x squared divided by x squared? 1. So this is a positive 1. Okay, now you want these to match. So if you want this to be a positive 2x, right, you're going to want to take out the negative there. So we're going to take out the negative 3. So when you divide, negative 6 divided by negative 3 is 2. The x stays with it. A negative divided by a negative is a positive, and then yay. Okay, so what's happening here is that these are common terms. If this is a common term, you can factor it out. And then the other parenthesis, which I usually put first, is just the x squared minus 3. Okay, so this is your final answer. Some people get confused with, hey, I had 2 of these and now I just have 1. It's because you're rewriting it as multiplication. So if I were to do this back, you are going to have to do some multiplying, right? If you were to multiply this, you would distribute the x squared and multiply it by this, and you'd find that out. And then you would take the negative 3 and you would multiply that, and you multiply that all out. And once you multiply it out, you end up with your original problem. So what you're really doing there is the distributive property. Okay, you're just doing it in the reverse method that you're used to doing it. You're factoring it out. All right, so now let's look at part B. So again, we're going to start with our factoring. So 4 and 8, I know I can take out a 4, x to the 4th and x to the cubed. How many x's can I take out? X to the 3rd. So this would give you x. Negative 8 by 4 is going to be negative 2. And then what can I take out of 2x plus 2? A positive 2. Yeah? So that would give me x plus 1. So if these do not match, which is what we have here, okay, if these factors are not the same, okay, we can't factor. Okay, so you can't factor it by grouping. Okay, do you guys know the only factoring you'd be able to do in this case? Yeah, you'd be able to take out the GCF, and that's all that you'd be able to do. You could also, that's what you're going to say, and then you could also do that first. Okay, it's just this one asks you specifically with the grouping method. Okay, all right. No, you wouldn't be able to do that. If they asked you to factor this, this would be your final answer. You'd have to take out the 2. It would be 2x to the 4th minus 4x cubed plus x plus 1. This would be the factored form. Okay, now how can you check to make sure that you factored the polynomials correctly? I said explain and then just choose one to check. Obviously, we're going to check this one because that's the big one that we have. Okay, so you can always check by multiplying them back together and using FOIL. So when you're doing a guess and check, you are going to want to check that. It doesn't have to be something that's written out. It can be something that you do in your head. So these are actually 2 binomials. So when you check them, you're going to use FOIL. You can also do the distributive method if you want to. But with FOIL, you always do the first term times the first term. X squared times 2x is going to be 2x to the 3rd. And this is where I use like sometimes I use my wheel. I do the inside and I do the outside. I kind of make a happy face guy with crazy eyebrows. So x squared times 1 is going to be x squared. Negative 3 times 2x is negative 6x. And then negative 3 times 1 is negative 3. And if this matches your original, you know that you did it correctly. Okay? All right. I'm going to give you time. We're trying to figure it over.